Hi everybody, so welcome to the day 2 of acing your SAT maths, and today we'll be starting with exponents and powers, which we were learning in your chapter language and tools of algebra, which was the very first unit of this. So let's go ahead with it and let me share my screen. And these all are basic things which you all must have been already knowing, but let's go through them. So yeah. Okay, so exponent and order of operation. So 3 to the power 5 is called a power. Yeah, so you guys must have also been knowing about laws of exponents, say a to the power m times a to the power n is a to the power m plus n, right? And when you divide, power gets subtracted, right? When it is the power to the power, right? The power get multiplied. Yeah, so these all things happen. So what is this? Right? Suppose if I write 3 to the power 5, so this number here, we call it as base. Okay. And its exponent, we call it as power. Okay. Exponent, or we call this thing as power, right? Now this tells you how many times 3 is multiplied by itself. Since here you have 3 to the power 5 means 3 is multiplied by itself. Remember, itself how many times? 5 times. So 3 times 3 times 3 times 3. Okay. Obviously, when you are doing the operations, you have to follow your BODMAS thing, which you have studied in earlier classes, right? You have to first see what is there in the bracket. Suppose any bracket is coming up, you have to first go inside the bracket. Inside that bracket also, what you'll be following? Division, multiplication, addition, and subtraction. So let's see how we do that. Okay guys, so let us look the very first example. We have 11 minus 20 divided by 5 square minus 13 by 3 plus 8 times 2, right? So where I see the bracket, I see the bracket, so I'll jump inside the bracket. I'll be solving the bracket things first. In bracket also, wherever I see exponents, I'll be trying to solve them, right? Write it in the normal form, and then I'll be doing my division, multiplication, addition, and subtraction. Okay, so here I'll write this exponent 11 take away 20 divided by 5 square is 25, take away 13 divided by 3 plus 8 times 2, isn't it? Now I'll write this thing with a proper bracket so that I do not do the mistake. Okay, so 11, now I'll be solving this division first, right? You can see the division here. I'll be trying to solve it. Before that, I'll simplify this fraction. Okay, before that, I'll simplify this fraction, right? So 25 minus 13 divided by 3, right? 25 minus 13 by 3. 25 minus 13 gives me 12 by 3, isn't it? So I'll be writing 20 divided by 12 over 3 plus 8 times 2. Okay, plus 8 times 2. Okay, now 12 divided by 3 is 4. So I can write this thing 11 take away 20 divided by 4 plus 8 times 2. 11. 20 divided by 4 is 5. 11 minus 5 plus 8 times 2. Isn't it? 11 minus 5 is 6. 6 and 8 is 14 times 2. So is 14 times 2 is 28, right? Now, is this type of problem, I'll tell you guys, you don't have to bypass the step. Okay, or else you'll end up doing mistake. Why? Because doing the mistake, you have much more probability of doing the mistake, much more chances, right? So every time you have put the brackets properly and solve it step by step. Even you also see I have done everything step by step. I've not skipped any step. Okay, so these are done with a lot of patience, and that's the way you guys also have to do it. Okay, obviously if there are options, you can check out the things what happens. Okay, now let's go ahead and see. Here we have variables given, and obviously these variables will be substituted with value. I think so you guys cannot see my what is the full question, so I'll just minimize this. And yeah, okay, so a cube minus b square plus c over a plus ab plus c, right? Okay, so what this would be, a is 4. I'll put all the values here. 4 cube, take away b square plus c minus 3 whole square plus c is 7 over a is 4. Yeah, I'll put this thing with a bracket. Why? So that I do not do the mistake. Okay, right. Then plus AB plus C, A times B, 4 times minus 3. I'll put this thing also with a bracket plus 7. Right? So I have two brackets. One bracket I have here, one bracket I have here. Let me solve. This one was easy, so let me solve this here. Okay. 4 times minus 3 is minus 12 plus 7. How much is giving me? Minus 5. So this thing gives me minus 5. Right? Added to what? Minus 3 square is 9 plus 7 over 4, right? This bracket I'm solving it here. 9 plus 7 is 16 over 4 is 4, right? So 4 cube minus this one is giving me 4 minus 4 minus 5, right? 4 cube is 64 minus 9. Minus 4 minus 5 is minus 9. So how much you are getting? 55 is the answer. That's it. Okay. So properly make the brackets and then do the things separately and then keep those values. You'll be ending up with the right answer. So let's go ahead and do these questions also. Okay, so let's go ahead and do these questions also. So what we have. Okay, so let's go ahead and do these questions also. So what we have here, a square bracket, and so whatever the bracket is inside, most inside bracket you'll be doing. Now we have again a power, so I'll write it first in the proper form. So this is actually 49, take away 9, divided by 8, and then 2, right? 49 take away 9 gives me 40, divided by 8 times 2, isn't it? This is times only if nothing is written. So 40 divided by 8 gives me 5 times 2, that is 10. Fine. Okay. Now here I see again two brackets here, right? This thing 3 is multiplied by this square bracket, and here you have a fraction like this, right? This whole. So this whole you have to solve it first before. Okay. So 2 to the power 4. 2 to the 4, 2 to the 8, to the 16. Take away 7 over 4 times 8. Isn't it? This I'll write it. I'm writing it separately. And 16 take away 7 is 9 over 4 times 8. So how much it is? 2. So how much it is? 18, right? So this whole thing is giving me 18. So I'll write 20, take away 18, and 19 minus 3. So what it is? 19 minus 3 times 20 take away 18 is 2. So 6. So this will give me 13. I hope you must have got this, right? Okay, now let's go ahead and do another problem here. Right, I have an exponent and here you have a. So what we do normally, right? Normally what we do, we multiply this thing and then divide. No, first always you have to simplify this thing. Okay, the exponent, and then divide and then multiply it. Okay, so let's go ahead and try to do this one. Uh, okay, so question number 3 now. 3 square gives you what? It gives you 9. Okay. So I'll be writing here. I'll be writing here 72 divided by 3 square is 9. All of this thing is multiplied by 2 divided by 6. 9 divided by 72 is 8 times 2 divided by uh 6. 8 times 2 is 16 over 6. So it's 8 over 3. Fine. Now let's go here. 5 cube. I'll simplify this. So 5 cubes gives me 125 minus half of this. First of all, inside the bracket, 12 divided by 3 is 4. So 12 plus 4, right? 12 plus 4 is 16, divided by 2 is 8. So 125 divided by 8. 125 take away 8. So how much it is? 117. That's what is the answer we get here. So I hope you guys must have got it, right? Bracket, then I'll hit the division and then addition and all. Okay, right. What is the value of 2c by a whole square times b plus ac? And so one I'll do, one I'll give you for a homework, right? So first let me put these values here. Let me put these values here. So I'll put all the values and 2c, 2 times 5, right, over minus 2 whole square minus 10 times b plus a. 3 plus of minus 2, right? I'm first putting the values only, not bypassing anything, and then 5, and then all the solve. First, I'll solve separately the brackets. 2 minus 2. So minus 5 whole square, right? I'll write this thing separately. I'll make a column. So that gives me 25. So this bracket at all, it's giving me 25 here. Okay, minus 10 times 3 minus 2 is 1 over 5. 5 divided by 10, how much it is? Minus 2. So the answer would be 25 take away 2. That will give you 23. Isn't it? So answer would be 25 take away 2. So that will give me 23. Okay. Right. So this question, question number 6, you guys have to tell me. There are 7, 8, all these you can tell me. Right now, simplifying algebraic expression, like terms, you guys must have all been studying from class 8th that what are like terms, what are coefficient. Okay, so like terms that are totally same, right? Many times we confuse that x and x square, these are like terms. No, right? Even if they have the same variable, exactly the term should be same, right? Suppose you have x square here, only the number should same. Here there is 5, here there is c, right? Whatever thing you have except the number, exactly same it should be, right? So 5x square and 3x square are like terms, but 3x is not a like term, right? Okay, got it? So you have say, hmm, you have say 5y square added to 2y. This will remain as it is, nothing you have to do. But if you have say 5y square added to 2y square, this would be 7y square. Exactly same it should be. Exactly same. You can add, subtract the like terms, right? But multiplication and division you can do with any terms, right? So addition and subtraction can be done with like terms. Only like terms, right? But multiplication and division you can do with all, right? Okay, so coefficient is what? Your number which is multiplied with your variable. 4 over 5 is the coefficient. Simplest form, you have to write them in equivalent expression. Okay, now distributive property, commutative property, and associative property. Okay, so distributive property is what? A times B plus C, right? You are distributing it. A you are distributing to B also, C also. So it will become AB times AC. So 4 times 7 plus 3 would be 4 times 7 plus 4 times 3, right? Commutative, you're forming community, isn't it? So A plus B will be B plus A, right? So commutative, A plus B, B plus A. Associative, you are forming association, right? So A plus B times C is A plus B plus C. Okay, so this is it. Now, commutative property is not valid for subtraction and division, right? Wherever order matters, commutative property won't be valid, right? Why? See, why I am saying this, see, 4 take away 3 is not equal to 3 take away 4. Both are valid for subtraction and division, okay? But here it is so subtraction and division whenever you had same way 4 divided by 3 is not equal to 3 divided by 4. So whenever you see subtraction and division, just be aware. Okay. Why? Because they are not valid. So let's go ahead and do some questions on this. Okay. So here we have some expression are given, right? Expression. Remember, they don't have equal to sign. Okay. So see now, first of all, I'll identify the like terms, exactly same terms. Okay, m is there, these two are like terms, and n is there, these are unlike term. Like term, I'll write them all together. Okay, so solution for a like term, I'll write them all together. So 1 over 3m plus, if you know how to convert improper mixed fraction into improper fraction, so 2 over 3, right? This number you multiply, this number you add. 3 to the 6 plus 2 8. 8 over 3 times m minus 4 times n. 8 plus 1, 9m over 3, so 3m minus 4m. Okay, that's what it is. Right, now let's go ahead with this one, the B part. So here you have 4x cube. I'll first of all use the distributive property and distribute this minus 2 into these two terms. So what will happen? 4x cube minus 2x cube minus 6x, I'll write. Okay. Now like terms, already these two are like terms. So just the numbers I'll subtract. 4 minus 2 is 2. X cube take away 6x. Got it? 2x cube take away 6x. And now we have this one, right? So A I'll distribute inside. So this will be 2A minus AB minus 2A plus 2B. Okay. So minus 2A plus 2A cancel. So 2B minus AB, this would be the answer. I hope you guys must have got this. So let's go ahead and do some questions. Okay. I will only do the first question and you have to do the rest of them, right? What else you can do, since they are expression, A and C can take any values, you can put the value and directly do that. Okay, so I'll be solving it also, and then exam how you have to solve that also I'll tell you. Directly you put the value, you do that. Okay, so see now, first of all, I'll distribute this half here and minus 3 by 2 here. Okay, so I can write this thing as half times 2a will give me a. Half times 3b will give me 3b over 2. Half times 4c will give me 2c. Minus 3 by 2b minus 3c. I hope you guys don't have doubt. Plus 3 by 2b minus 3 by 2b is get cancelled and the answer would be a minus c, the partial D. Okay. How I will do this one? I'll put A equals to 0, B equals to 0. Why? Because see, A I have the same in that, right? So even if I get a value of A, I won't be able to judge. And C, suppose I put 1, right? So A 0, this term is gone. B 0, this term is gone. C, 4 by 2, I get 2, right? B 0, this term is gone. 3 minus 3 by 2 times 2 times 1, isn't it? See, so or at the end I got minus 1. Answer should have minus 1. See, C was 1, A was 0. So this is giving me minus 3. This is giving me 5. This is giving me 1. This is giving me minus 1. So answer will be D. Isn't it? So both way, this all methods you have to use in SAT. Okay. To get the answer by putting up the value. Since it's an expression, we can put any values here. Equation also you can put, but the value should satisfy. Okay. Now let's study about rational, irrational, and decimal numbers. Okay. So, okay, now you guys have, let me tell you properly here. Okay. So, yeah. Now let's talk about that. Okay. So you had a number line like this, right? Okay. Your number line before it was starting from 1. Okay. I made a very good video on rational numbers. I'll put it in my channel. Okay. And you guys can watch it if you want it, because your basic of maths would be clear then. Okay. So, right? So 1, 2, 3, 4, 5, 6, you put it. These are what natural numbers, right? Somebody would have imagined for the very first time, right? He wouldn't have imagined something like 0. Okay. So that is why he kept a one stick like on the ground. So that is why these are called naturally they occur. Okay, so that's what natural number, right? After a lot of years, 0 was invented and made the whole thing change, right? Actually, what happens, 0 gives a very good system of counting. If you place 0 on the right hand side, the value of the number increases. 10 becomes 100, it increases by 10 times. And if you place this on the left hand side, nothing changes. So it gave a system of counting also. So it certainly gave us the whole counting. Okay. So these were the whole number. Only difference between whole number and natural number is that whole number, they have 0 also included in it, and natural numbers just they start from 1, right? Now remember guys, we are only talking about these specific points on the number line, right? These specific points only. Okay, on the number line, like this 1, 2 specific certain points. Okay, now When this things are coming, right, we got integers, something you call it as integers. Okay, so what happened, the integer gave us the direction. You are going in the positive direction, you are going in the negative direction, isn't it? So 0, 1, 2, 3, and then you start taking the direction, isn't it? You are going up, you are going down, so this gives us integers. Till integers we are talking about the specific points only. Okay, and then what it gives, and then what it came, then your came as rational numbers. Okay, what are rational numbers? 0, 1, 2, 3, 4, minus 1, right? So till integers we were talking about the specific point, right? But rational number we started talking about between the numbers also. Okay, so these are the numbers like you have say half. Okay, you have say half, or you have say 3 over 2 or 1.5. You are talking about between the numbers, right? So p by q form, the number can be written where q is not equals to 0. Rational numbers, you are taking the number between the points also, so whole of your number line covered up. Okay, but even there are some numbers which do not, you cannot write it into fractional form also, and they do not repeat also. I mean, they do not repeat also, right? Like, so these are what your irrational numbers. Okay. So you have 1 and 2, and there are some numbers, right? Like you have say root 2 here. Okay. So what it happens, non-repeating and non-terminating, right? 1.732, like this value will not repeat also or not terminate also. Okay. So this is what it is. Pi is one of those number. So these are what irrational numbers. Okay. Non-repeating and non-terminating. Okay. Rational number, they terminates. So that's what this all theory is about. Okay, so rational number written can be a by b form where b is not equal to 0. Okay, and they have the decimal form, but here they are not repeating and non-terminating. These are irrational numbers. Okay, now rounding of the numbers. Suppose if you have to round some numbers, say 46, you have to round up, right? So whatever number, round up to the, I'll say ones place. Okay, or say tens place, you round it up. Okay, so what you have to do, you have to look the number whichever you are rounding. So that place I'll be looking up, say ones place I'll be rounding. Okay, so tens place I have to round, right? So ones place I'll be looking, you'll be looking at the right hand side. Okay, so tens place, this number I have to round, so I'll be looking it in the right hand side. Okay, I have 6. So if this number is more than 5, right, you will round up. Okay, round up which number? This number would be rounded up. Okay, if it is more than 5, right, so 4 would be rounded up 1, so that will, you'll write it as 5, right? If this is less than 5, then 4 will remain 4 only. Got it? That's the only thing you have to do. You have to look it on the right hand side. If it is more than 5 or equal to 5 also, you'll round up. Less than 5, you'll make it as it is, right? So this would be written as 50 if you have to round up. That's it. Okay, on number line spaces, what are the coordinates of p? Okay, so 0, 0.25. 1 is 0.25. So how many gaps you have? 1, 2, 3, 4, 5, 6, 7 gaps are there. Okay. And then this thing. So 7 times 0 minus 0.25. You will do from 0.25. So it would be minus 1.75. Okay. 52.5 rounded to the nearest integer. Okay. And 100. Nearest integer. This 2 I have to round up. I'll look right hand side of the tree. Is it more than 5 or less than 5? It is less than 5. So this would be just 52. I'll write. Okay. Now 100th. Remember, 100 is different. 100th is different. This is 10th. This is 100th. Right. So 52.348. This is the 100th. Okay. So this is 4. I'll look on the right hand side also. Yes, it is more than 5. So this is rounded up to 5. So this will become 52.35. That's it. Okay. You guys must be knowing this very well. Now, yeah. Arrange the number in the increasing order. Okay. Arrange the number in the increasing order. Let's do this. Okay, so let's do this. Arrange the number in the increasing order. So you have some number. First of all, look them in the right. All numbers are same in the column. So you have 4, which is a positive number. Obviously, negative numbers would be there at the last. Okay. And 3 positive numbers. So they should be coming first. Right? Okay. Right. I mean, they should be coming at last. So they are coming. Right? Okay. Now, root 10 is like 3 point something, 3.333. So 4 will be at the last. So 4 is here, 4 is here, then root 10. And then obviously 2 by 3 since it's positive. Right? Okay. Now minus 5 and this is minus. So this would be the option C. Right? Minus root 3 is minus 1.73. Obviously in negative, the magnitude is bigger. Minus 5, 1.66, 3.3 and then 4. Okay. Let's go ahead and do the second one which we have here. Okay, so 11 take away 2 in bracket. Obviously, first I'll write the exponent properly and then the division and then write the whole thing. Okay, so let me write it properly. 11 take away 2, 2 take away 0.64, isn't it? Plus 24 divided by minus 4 is minus 6. 2 take away 0.64 is how much? 1.36. 2 times 1.36, right? How much it is? 2.72. 11 minus 6, isn't it? So 5 minus 2.72. How much it is coming? 2.3, 2.28, isn't it? 2.28. Okay. So this completes our chapter 1 for it, and the unit 1 also, the languages and tools of algebra. If you guys want a chapter test and some questions to practice on this, I'll give you, and in the next video we'll be starting with solving linear equations. So thank you.